Fresno State Physics Outreach is a group of science students learning to teach science. And here now is Don Williams, the professor behind the Traveling Student Scientist Group. And today we're talking about something that we should all talk about on a Monday.
I hear you.
And I need a little bit more of it today. We're talking about energy.
Energy.
All right, so before we get into energy, for anybody who has not seen Don Williams before, this is what he does when he goes around to the Central Valley, to kids, to wherever they need a scientist. You are teaching science and kids how to teach science through activities. So how are we going to explain energy today?
Yeah, well, we could start with something people. Do you remember when you were a kid? Did you ever do this? Okay.
Oh yeah, a little swing.
Little swing.
Yeah, I love the swing.
That's a conversion between kinetic energy and potential energy.
Okay.
Right? The potential energy is the height, and the kinetic energy is the motion.
The motion,
yeah,
right?
Yeah.
Okay.
And then how about this cute little one here, huh?
Cupid's arrow.
Yeah, Cupid's arrow. So this actually, I'm storing potential energy. This is elastic, potential, elastic, and then I turn it into kinetic
energy.
Yeah.
Oh, okay, that's a good example.
That is, isn't it?
Okay.
Now let's talk about this energy thing, because we all eat food and we talk about 2,000 calories, but we know the real writing on the wall here, when they say it's 320 calories, that's 320,000.
Okay, explain this to me. So these Cheetos have 330 calories. Usually, you know, it'll be there when you go to McDonald's or whatever. It has it up on the board.
Yep.
But what were you saying?
It's truly food calories, which are really kilocalories. So that's really 320,000 calories.
Okay, but when the nutritionist tells me I need 2,000 calories a day,
they're saying food calories, but they're really 200,000.
200,000.
They really are of the real
so it's not like I need 2,000 calories and I'm eating the whole calorie amount.
That's how they fudge it a little bit. They don't have all those zeros.
They don't have all the zeros.
Yeah, exactly.
Well, thank God, because I can't comprehend that many zeros. Okay.
So the bottom line is they tell you to eat about 2,000 calories a day, right? Okay.
Yeah.
Now, I wonder if I gave you like this barbell to lift over your head. I know you can do that, man.
Let's see.
So like, you feel that? Look how light that is. So press it over your head.
Okay.
Okay. So here
press.
you go.
Okay.
So now go down and then press and do a rep. Okay, and then up. There you go. All right, let's see how many calories you burned, guys.
Oh, wait, you can tell.
I can tell roughly. You know why? Because I can figure out how much this weighs, right?
I thought there was like a meter in there.
No,
okay.
It's like, can you imagine if it was heavier? Would it be more calories you'd be burning?
You'd be burning more calories, yes.
So that's about 60 newtons times, let's say, 2 meters. That's only 140 joules, and that's like about 0.000 something calories you burned on one rep.
That was useless. I did nothing.
But now here's the thing. Human beings burn calories naturally.
We're burning calories right now by talking, by being awake.
Exactly.
Okay.
Breathing fun. Now let's talk about fun stuff like roller coasters, right? Now here's what I have. Is I have kind of a little simple loop. Now the rule is, like even on a water slide, if you start at a height, you should be able to make it up to the same height, right?
Yes.
So it should go over to the other side here. Okay. So I'm going to release it. And it made it, but it didn't make it back because so much friction that I have actually. But I'm going to change.
So friction is not energy's friend.
No, exactly. Emily, good job. Exactly. Friction is not. Now I've got a much heavier ball. Watch this. It'll go back over actually.
Oh.
Because it has more inertia, so it keeps wanting to go. It kind of overrode the friction, right?
Oh, this would be good for our little box car or the weighted cars that you do in Awanas.
Yes.
Okay.
Now, let's move that over a little bit, and let's move this thing down now. Now, this is like a loop. We've all done loops, man. We love loops, except Don's not. That's not my favorite. Debbie loves them, right? But anyway, theoretically, if I put this ball at the same height as that,
it should go around.
It shouldn't it?
Yeah.
But it's not because of that F word, friction. Doesn't make it.
Oh.
So we've added it a piece up here to give it more potential energy.
Yeah.
So it will make it around and we can actually see it happen, all right? 1, 2, 3. There it goes. Does a little loop, exactly. Now, all of this stuff culminates in, like, we're going to go through the whole process. Like, you had breakfast this morning, right? Now, I know you didn't eat this stuff.
I did not have Fritos for breakfast,
But we know some people do. Some people eat
I had a cup of coffee for breakfast. I don't know if that was much.
That's not breakfast. That's not breakfast. Now, here's what I'm going to do. So I'm going to imagine I eat Cheerios, and I have fruit, and I got those calories, right? Now I can do work, all right, Emily? So now I can take my sand, and I can lift it up, and it's gaining energy, right? And then I'm storing it in there.
Okay.
And I can put a little more in there, so I ate enough Cheerios and fruit, I got enough calories, I could do all this work, right? Lifting weight up in there. And then what I can do is I can take this thing, I'm going to have you do it, push that button forward, and watch what happens. Just push it forward hard, and watch what happens. There it takes and spins the wheel.
Oh,
it makes a little mess. So all of that energy now turned into motional energy. It's like a water wheel.
Yeah. So when we hold energy up there, would we call that
stored energy?
Stored
energy, and we turn it into
potential energy.
Well, that is stored energy.
Oh, okay.
Potential energy. And this was stored potential energy stored in elastic material.
And these are the three types of energy that we've covered. Did we talk about gravitational energy?
Now,
gravitational potential energy.
Exactly.
We talked about kinetic energy. That's something in motion. How about conservation of energy?
That's the idea of taking one to the other. So see, what we do is we lift it up like you tick top to the top on a roller coaster, and you've gained all that potential energy.
Yes.
So you have it, it's stored, and then you turn it into what? Kinetic energy.
Kinetic energy.
Exactly. Now, we're going to go to a ramp here.
All right.
Okay, a simple ramp. Now, I'm going to roll a couple of things down the ramp. Now, I've got a wheel that'll roll down the ramp.
Yes.
Okay. Now, do you agree, since it's got height, it's got potential energy?
Yes.
Turning into what kind again?
Kinetic energy.
Beautiful. Right on. All right. Now, I've got a hoop. Now, they actually weigh the same. I didn't bring my scale in, but I'm going to tell you they weigh the same.
All right.
You see they're the same diameter, Emily.
Yes.
I'm going to let them go. Let's see what happens. 1, 2, 3.
Oh, I knew that one was going to go faster.
You did?
Yes.
You did? What if I switch sides? Is it still going to go faster?
Yes.
Still is?
Yes.
Why did that
I don't know.
go
It's dense. It's more dense.
You're kind of on the right track. It's how where the mass is located with respect to that axis. See, the axis through the center. This is evenly distributed. Is this all far away from the outside?
Right.
Okay, now I got another one. Take a look at this. Let's take a look at this and this.
Okay.
What do you think is going to win, or is it going to be a tie?
I think it's going to be a tie.
You think it's going to be a tie?
Yes.
Okay. Okay, here we go. 1, 2, 3.
Oh!
That guy still won. Why did you give up on that guy?
I don't know.
You know that guy? That hoop still lost because all the weight is far away. Now, let's do this. What about if we take this?
And that? Let me see how much they weigh.
They're definitely different in weight, too.
This one's going to go faster.
You think they're going to go faster? Now, what I want you to notice is they're both hoops. Are they both hoops?
Yes.
Here goes the tie.
Yeah, they tied.
They have the same shape.
So these are all demonstrations of science, and this is a great thing for somebody like me. You know, I cannot do math or addition, but I can understand things if I can see them. And you guys are actually going to be showing a whole bunch of this stuff off at Vintage Days, which you're going to. Dawn's going to stick around. We're going to talk about Vintage Days at the end of the show. We're going to make a little sweet treat with science too. So you're going to stay here. Everybody else, you stay there, because coming up here in Central Valley today, it's always a great time to reevaluate your finances and your insurance, how to make sure you're getting the best rate and the biggest discounts with Sioux Casa Valley Insurance. That's when we come back. Stay there.